InterviewPro. In today's video, let's solve the LeetCode problem High 5. This question appeared in interviews by Goldman Sachs and Amazon. The problem gives the list of students and their scores. We have to return the average of top 5 scores of each student. Let's see this example. We have two students, student 1 and student 2, and the scores are listed like this. To get the top 5 scores, let's sort the scores in descending order. So the first student marks would be like this, and the average of the top 5 scores of this student will be 87. And then we have student 2. Let's sort these scores as well in descending order, and the average would be 88. We need a data structure to store the sorted scores and also the list of students. We can make use of a dictionary which uses student ID as the key, so that it would be easy for us to get the list of scores for a particular student. And then each student ID key will have the list of scores as value in the dictionary. These scores have to be sorted in descending order to get the top 5 scores. So we have to first get the array of scores because the scores is not given in the form of an array in the question. So first we have to form an array of all the scores for a particular student and then sort them in the descending order. Instead of using an array and sorting them in the descending order, we can make use of a priority queue as well, right? Which sorts the elements as we push the scores to the queue. And after processing all the records, we have to return the average for each student ID like this. So the output for this example would be 1, 87. That means average of the student 1 is 87. 2, 88 means the average of student 2 is 88. In the given example, the first input is 1, 91. That is, one of the scores of student 1 is 91. So we'll create a key for student 1 and assign a priority queue with the value 91. Then the next input is 1, 92. We have to insert the student 1 key is already existing in the dictionary. So we just have to insert 92 to the priority queue. And since this is a priority queue, 92 will be coming first, then we'll have 91. As we want the scores to be sorted in descending order, we can use our custom comparer and make it store highest elements first. So 92 will come first, then it will be 91. And the next input is 2, 93. Our dictionary currently has only key for the student 1. Now we have to create another key for student 2 and insert a score 93 into the priority queue for student 2. Then we have 2, 97. The student 2 key is already created in the dictionary. So we just have to insert 97 into the priority queue. Then we have 1, 60. So insert 60 for student 1. Then we have 2, 77 for student 2. 65 for student 1. 65 is greater than 60. So now the queue will be 92, 91, 65 and 60. Then we have 87. 87 is also greater than 65 and 60. So it is sorted accordingly. Then we have 100 and the priority queue is sorted based on the descending order. Then we have 2, 100. 100 will be inserted into the priority queue of student 2. Then 2, 76 for student 2. Now our final priority queue and dictionary will look like this. Taking the average of the first 5 scores of student 1 will give us 87, and taking the average for the first 5 scores for second student will give us 88. Since this is a priority queue, which is nothing but first in first out, we'll get the top 5 by dequeuing. So let's see how we can write this in the code. This is the problem statement, and let's code in C#. So now what we need is a dictionary. But look at this problem statement. It says sort result by ID in increasing order. So we not only want the scores of each student in descending order, but also we want the IDs of student to be in increasing order, ascending order. So instead of using a dictionary, there is another data structure called sorted dictionary, which is similar to dictionary, but the thing is the keys that we insert into this dictionary will be in the sorted order. It will be ascending order by default. So our dictionary will have integer as a key and will have a priority queue as the value. And this priority queue will have integer elements, and the priority will also be specified in integer. So this is our priority queue, and let me name this variable as dictionary. Then let's loop through each of these items from the given item. So for int I equals 0, I less than items dot length I plus plus. So we have to check if, for example, the first in the first iteration we'll get this array. So we have to see if the first element in this array is present as a key in the dictionary or not. So if dict dot contains key of items of I of 0. If it is already present, we just have to push it to the queue. So dict of items of I of 0 dot enqueue items of I of 1. We have to put 91 into the key. So that 91 will be available in items of I of 1. Then we'll specify the priority also with the same number. Now, if the dictionary doesn't contain this key, what we have to do? We have to insert this key and create a new priority queue for it. So let me create a priority queue for this key. Items of I of 0 equals new priority queue of int comma int. Now we have created a priority queue for this item, and then we have to push this item into the queue. So I'll copy the same thing here. You can simplify this code because this line of code is common, but for better understanding, I'm just putting it like this. Now we have created a dictionary with the priority queue. So our structure will be, for every key we have an array of or a queue of scores. Now what is our what is expected result? The result should contain ID of the student and the average of the top 5. So to store the result, let's create a list of integer arrays. I'll name it as result. Now list of integer array. Then for each of the dictionary key, so I'll say where student in dict. So student will now have student ID and the priority queue. And for each of the student, we have to calculate the sum. So I'll create a variable sum assigned to 0 initially. Now we need only top 5. So I'll take a loop which will iterate for 5 times. In this loop, I'll simply add the elements from the queue. So to access elements, student dot value dot dq. We have to take elements out of the queue. Finally, once we get the sum, we have to add the average to this result. And the result should be in the form of an array with 2 elements. So let's create an array. with two elements. The first element would be student dot key, which gives us the ID. Then it's the average, so sum by 5. So our logic is ready. Finally, we have to return this result. This result should be in the form of array. As of now, we have taken this in the form of list, but the expected format is array. So I'll simply convert result to array using toArray. The priority queue will sort items in ascending order by default, but we want it in the descending order. Let me remove these comments. So in order to make this priority queue sort our scores in descending order, we need a custom comparer. So I'll create another class, public class my comparer. This comparer should be implementing iComparer of interface, and this iComparer will have a method called compare, which takes two parameters. I'll name them a comma b. The comparison is made between integers because all our scores are integers, right? So the parameters type would be integers. So int a and int b would be my parameters. If a is greater than b, we have to return -1. If the value of priority is less, that element will be considered as the highest priority element in priority queue. So if A is greater than B, we'll return -1. What happens when I return -1? A is considered as the highest priority. So it will move to the front of the queue. If this is less than B, if A is less than B, this is of less priority. So I'll simply return 1. If both are equal, we'll simply return 0. Let's make use of this comparer. We just have to create an instance of this class here. And we are done. Let me run this. Okay, there is a typo here. Items. Okay, there is a typo here as well. Items. Let me run again. Okay, there is another typo here. DQ. The cases are satisfied. Let me submit this. And the solution is accepted. Coming to time complexity, we have n items and we are using priority queue to insert those items into the proper queue. So the NQ and DQ operations of priority queue will take log n times, and for processing all these n items, it would take n log n times. Then we process through each item of the dictionary and also each item of the priority queue. So this operation will take big O of n times, big O of n plus big O of n log n, which would give us the overall time complexity of big O of n log n. Coming to space complexity, we are using this dictionary and priority queue to store n items. So the space complexity is going to be big O of n. I hope the solution is clear. If you like the content, please like, share and subscribe to InterviewPro. Thank you.